Our next presentation is by Dr. Clifford Schneider, Emeritus Eminent Scholar, Arizona State University, and Christine Fiore, Virginia Tech University. Dr. Schneider and Fiore will speak on the Inca and modern engineering in the Andes. Dr. Fiore?
We almost became a family, or we did become a family working on this project. And I'll give you a little background. I can't tell you how many years ago, but Romero went with us to Machu Picchu. We went there with the American Society of Civil Engineers because we dedicated it as an international civil engineering landmark. And while we were there, he was talking to Christine and I, and he said, "I want to do an exhibit." And we said, "That's a great idea." And we became part of his family to make this thing happen. Our third partner, and I'll introduce him in a minute. Let's see, how do I make this thing work? There we go. So Chris did all the work. We came back here. She's at Virginia Tech. She puts a proposal together to the National Science Foundation. Romero's friends here at the Smithsonian go with us, and we tell them what we want to do. And we get some money from them to do it. Together with that, the Universidad de Piura, we have the former Dean of Engineering, Susana, sitting back here. Stand up, Susana. Geraldo, who was with us on all the expeditions, joined us. Okay. They partnered with us. We had the extra funds from the Science Foundation. The Smithsonian helped us also because they paid for satellite equipment, and every time we went up there, we broadcast back to this auditorium, and you could ask us questions, and we could show you where we were on the road. The State Department was here this morning. We had all this technical equipment, the satellite gear and everything, to get into Peru and out of Peru. The State Department met us, helped us get through all the processes and all the paperwork that I'd have just gotten lost with. This is the first team because we came here to the Smithsonian. We sat down with the people that know a little more about this because we're engineers. We're not anthropologists. We thought it was just a great idea. Manuel, University of Texas, El Paso. We took ground penetrating radar to look at this road and what's underneath it. Our Yama driver, who stayed with us all the time, Geraldo Chang, we just introduced. Our guide, we needed somebody that spoke Quechua. Chris. Megan Song, you back there, Megan? Where? Where are you at, Megan? There she is, way in the back. Megan Song walked this road from Quito to Santiago. That's 3,000 miles. I wanted to know where to look at a bridge or where to look at water. We asked Megan, and she took us there. She's got this trapdoor mind. She knew where everything exists because she walked it. Ed Jaselskas, North Carolina State University, myself, Aaron Haynes, we took a linguist from Berkeley to help us with the different languages. That was the first year just to see what we were getting into. We went back again. And this time we took engineering students from the United States, from Peru, from Argentina, from Chile. We even took a young man from Thailand with us. These were all engineering students to help us with this and also to get them into this research. To check on some things, we went back a third time, the three of us. Guido here took care of all the arrangements and the trips down there. A great asset to help us make this a success. Here's the Inca Road. You've seen this map, different folks today. If you stay up in the high Andes, about 3,500 miles. The high Andes, 10,000 feet, 15,500 feet. I was breathing real hard. Colombia, Ecuador, Peru, Bolivia, Argentina, and Chile. when you get down here to Santiago, Chile, I don't have a map of the world to show you, but you are at the bottom of South Africa. This continent goes all the way down to Antarctica. This is very different. You think about, most people, they just say, oh, South America, they're about the same. No, it's not. This is much longer, much further south to where it really gets cold down there. So the conquistadors came. And you've already heard people talk about how amazed they were. I've worked on road projects from here in Virginia all the way to Thailand. Went down to Chile after the Mao earthquake. This is a major project. This is a magnificent piece of engineering. This is what the soldier that walked it, Cesar, he just couldn't believe it. You heard him talk about the bridges, my friend from MIT. Those conquistadors, 20-something against thousands of Indians. These were crazy dudes. 20 guys in the middle of nowhere, thousands of Indians. They saw that bridge that he talked to you about. They got off those horses and they literally crawled across them the first time. How did they do it? Just building it, that's actually pretty easy. Let me tell you a little bit about the landscape that we missed. This is Pisac. You've seen this picture before. Those terraces. I believe that Inca engineering, like many civilizations, started with agriculture. You're in the high Andes, you have very little level ground, and you need to eat. And so what the Inca did, they mechanized this in the sense that they organized the people. They learned how to build those walls. They learned how to control that water so that it drained down all the way down, kept irrigating each terrace. And so they gained a knowledge of water. They gained a knowledge of building the stone wall. All those beautiful stone walls you see at Cusco came from things like this to begin with. Okay. He asked you when we started today, and I just got one of these, I just have one of these flip phones, but I've seen some of these other things around here. They didn't have a written language. I'm wearing this hat right now because if you go over in the mall right out here and go look at them, and you'll see them doing this weaving. They start as little girls, and this is a band from a little girl at Pisac, and this is a hat from Pisac. And so she's probably less than 10 years old. She's got no written directions of how to do this weaving, to put that formula, that pattern on there. Go looking tomorrow. Take a walk out here and watch what the ladies and the men are building. There's no written thing there. They do it all from memory. So without all these gizmos and these things we have and television and the rest, you took something in your brain, you loaded that onboard computer, and you took it out there as an engineer and built this road or built that farm terrace or controlled that water. You knew it. You knew it from doing this, the weaving. That rope is about weaving. My wife was fascinated today watching them because they do the same way she does her yarn. They learned it from those skills, and then it got applied to engineering. This is up in the highlands of Peru. This is market day. Fruits, vegetables. You had to be able to produce enough food that you had extra workforce to build the road, to build the empire we've talked about. Until you could produce enough food, enough extra food, so somebody didn't have to be farming, you couldn't build this empire. You couldn't build all these buildings we talk about in this road. Wonderful stuff. Pachamama provided. When they built the road, they protected. If this was good crop land, there were walls on the sides so you didn't get over there. Your llamas didn't get there, and we're talking about llama caravans that had 10,000. Lots of llamas, lots of animals. This would be a narrow section of road because it's good farmland. If you lived in Europe at this time, and you weren't the king, you got smushed beans made into soup, and that's what you ate 3 meals a day. If you lived in Peru, in the highlands, oh, we had potatoes, we had cuy, we had tomatoes, we had lima beans. We had things that they did not have in Europe. Until that potato went to Europe, boy, it was a tough diet. But here's the other piece, that piece about the no written language. They took time to study nature. They worked with nature. Pachamama could provide, but she's got lots of energy. This is just a rain. This is not El Nino. This is the river at Agua Caliente. This is where the train lets you off before you go up to Machu Picchu. Just a good rain. It took out a whole bunch of modern bridges. The Inca and their engineers watched these things and studied them. And you've already seen the thing about the different types of bridges. Those piers were there 600, 700 years now we're talking about. Oh, yes, they have other things like hailstorms. This is Geraldo and I running from a hailstorm that's coming up behind us when we were walking one day south of Huaynucopamba. We're trying to get into some shelter. Pachamama is a very forceful mama. Seismic events. This is a small one. 2/3 of the major earthquakes in this world of ours, this planet, they happen right here on this ridge line of South America, western South America. You go look at Machu Picchu. There's one place that I know there's a crack. You go look at the road. You look at those Inca bridges, those doorways, they look like this. They know about earthquakes. They know about that moving earth. This is the environment they studied, they paid attention to, and then they did their building. Chris, it's all yours.
So as Cliff had said, the Inca worked in harmony with nature. They respected Pachamama. They understood the forces of nature. And they really understood the energy associated with nature and the energy associated with doing just about anything related to building or traveling along the road. So we're going to talk a lot about the energy of nature, and I'm going to start with water. And the understanding of water for the Incas and the movement of water and controlling water. We've heard from the rites with Machu Picchu, and we also hear Tapan. The Inca understood that energy of water. Now, if you look at this picture here, what you see on the road is this area right here. This isn't paved. There's no paving surface on here. There's no stones. And in areas where water would run over the surface of the road, where it was very wide and wasn't steep, and where there wouldn't be a lot of water running over the surface, there wasn't paved structures. What you had was a grassy area, and the energy associated with the water was dissipated over that surface. So it didn't erode very much. Now, as we moved through the highlands, what we began to see is the Inca engineers would build steps into their roads when they needed to overcome a steep grade. But generally, we would find these, what we appeared to think were steps, in kind of random sets of 2 or 3 that would run across the road. And after we discovered these in several different places, especially in areas where there wasn't a steep location, and knowing the amount of energy that it takes to actually construct these particular sets of steps, we began to realize that these were not steps used to traverse steep grades. They were actually steps that were used to slow down or dissipate the energy of water. We found without these steps there to actually dissipate that water, many of the areas that we worked in, the road would actually have washed away. So what right here is an example of these, we're calling them steps. They're really just raised stone drains. What would happen is if you think about the amount of rain and snow melts, they're really major environmental forces that can cause havoc and really erode an actual road system. So in this particular picture, what you see is this is on the slope coming from Tambio up to the pass at Huagapunta, which on our first expedition, that was our highest point, and we were all just gasping for breath the entire time as we reached to that top. So we stopped a lot and looked at these steps, and a lot of it was, we said it was for science, but we were really just tired. We stopped and we looked at these steps, and what we saw, and we were able to confirm things that Hyslop had seen in terms of where the steps were and what they were used for. And as we walk up to this pass, you begin to see that areas where the road began to get steeper, they started to begin to pave the roads. Now, this contraption right over here, okay, was our ground penetrating radar system that Cliff mentioned. We had an interesting time trying to get it into the country and out of the country. And we brought that with us because we expected the Inca roads to be very similar in structure, at least in terms of their foundations, to Roman roads. So we thought, we're going to bring this ground penetrating radar, we're going to see what's underneath there, because we couldn't dig anywhere. We had to use the ground penetrating radar as our eyes. And what we found when we began to look at the paved sections of the roadways, we'd see paving on the surface, and generally where you would see the paving, it really was just to control the energy of water so that the water would not erode the road away, and there was just considerable thought and effort put into protecting this road. So this is continuing up to the highest point on our first trek, and as the road got steeper, the paving stones were there. We expected to find them very deep within the subsurface, but our ground penetrating radar told us differently. So we were hoping to find excellent foundation systems and structures, and we didn't find anything. So we were all thinking, well, we drug this ground penetrating radar thing all the way from the US. We're going to use it on just about everything. So we looked at the roads extensively, trying to find something. We did find some information about the paving stones, and I'll tell you a little bit about that later. But when you look at this road system and you see the paving stones right here, it's in a steep area where water and snowfall, as it's running off the mountain, would potentially erode the road away. But if you think about the road surface in terms of the durability of the road for having people travel across it, the Inca road was not designed, okay, to handle our vehicles like we have today. Remember, they weren't using the wheel. There weren't any loaded carriages or anything moving across these roads until the Spanish came. The roads were designed to be used by humans, okay, walking in sandals, okay, and llamas. Okay, and llama feet don't damage the road like a horse's hoof would, because they have their feet are soft and bump-footed, and so they don't tear up the road, okay, as they move across it. Now, the chroniclers have said that they encountered caravans of llamas with tens of thousands of llamas in them. So as they were moving across this road with people walking in sandals and with llamas walking on their nice little undulated feet, did not cause any damage to the road. So we soon began to realize that the paving was not there for wear and tear. It was really there to protect the road from the water moving over the surface. But we still drag out our ground penetrating radar anytime we had the chance. And what we did was we actually did surveys north and south of Ayash along the road to see what we could find. In areas where we actually did find road paving, what we found is that the thickness of the road paving was no more than about 20 centimeters or about 8 inches is what we found. That was the deepest thickness of the rocks that we found. And again, it was in areas where there was a lot of water that would be running over the road. And so this is our ground penetrating radar system. And when we began to look at the road system overall, and we realized that, all right, we're not going to find what we thought we were going to find, so we really need to look at a different theory of why this road has lasted so long. And I'm going to go back to the energy of water and controlling the energy of water. The road is often located in the upper reaches of slopes where streams and that have a small amount of flow, you actually have to cross them. And the Inca did move the water across the road, under the road, and away from the road in many different ways. This slide here shows a couple of different ways that the Inca controlled water. And the first here, the raised stone drains, I was referring to them as steps earlier. These raised stone drains served to move water across the road. You also had open-lined stone culverts. You had culverts that were capped with stones, which could be considered as a bridge of some sort. And we also had areas where you actually had a full-fledged culvert that was covered over by the road and the water would run underneath it. Now I'm going to show you some examples of each of these. So here's a raised stone drain, and it was always constructed perpendicular to the travelway for purposes of shunting water to either side. And what we found is, based upon our limited observations, we have traveled on this section of the road. We probably did about 50 miles of this section of the road overall, looking at it. And what we found, based upon our limited observations, was that the raised stone drains seem to be more popular in areas where there's grassy areas where there isn't any paving stones. Okay, so most likely where the water is not running that quickly and can be moved to either side. Another way that the Inca controlled water was with these open stone line culverts here. And what these would do is they would move water from the high side of the road to the low side of the road and move it directly across. Now you see these open stone culverts didn't have any problems because in interrupting travelers or anything like that, 'cause people would just step over them. The llamas really didn't even seem to mind them because again, they weren't utilizing the wheel. Now, if you look at these stone culverts, you can see that there is some growth in the middle of these. Now, I don't know about you all, but after 500 years of no maintenance, I think they look pretty good. Can you imagine, any street in the U.S. if they didn't maintain it for 500 years, what it would look like? So some of the deterioration of some of these drainage structures is kind of what's influencing the stability of the road. Now, we came across some bridge structures as we moved across the landscape. And what we found in this particular area is we began to look at the culverts and where the water was moving through. And we realized that these culverts were sized appropriately. Again, the Inca were genius hydraulic engineers. I was speaking with Ken and Ruth yesterday and saying, they may not have known what Manning's equation was. Sorry, the civil engineer in me had to get at least one equation out there. But they adhered to it, okay, in terms of how water would flow. And they sized these culverts appropriately. But as we looked closer and crawled inside of them, what we noticed is that on the high side to the low side of this particular river that we were crossing, in these culvert areas, there were steps within the actual structure. And you can see here in this picture that on the high side of the river, the water would have to travel over several steps to dissipate energy so that when it came out on the other side, it did not erode very badly the other side, the downstream side of the actual bridge. Okay, so not only were they controlling water along the road, they were also controlling water through their structures and sizing them appropriately. Now, many times we found these stone culverts, okay, these capped stone culverts with open line stone drains and also other stone curbs and drainage ditches, all used in conjunction. So in areas where there was a lot of water moving, whether it be a stream or an area where the mountain runoff was going to be really high, we saw each one of these particular ways to control water used in conjunction with one another. So they had lots of different ways to deal with the water. And in this particular picture, we're trying to show you here is that these side ditches and stone curbing, very similar to what modern day engineers use to move water along the side of your roadways. But they really were paying attention to make sure their roads were actually waterproof. This particular picture is climbing up to the, I'm going to pronounce this correctly, the Wakachura Pass, where we were moving north, and we noted that as we were coming up this pass, it was very steep, so you notice that there is some paving stones, and we also saw a prevalence of these stone ditches on the side to move a larger quantity of water. Again, we did find some of these open stone culverts across the road there. And so when we looked at we didn't find what we expected, but we had to look at a different theory of why the road is still intact, and it really is because of the way that they controlled the water and managed it. Another way that the road has maintained itself over all these years is the retaining wall structures that you find along the road. They handled the side slopes in a number of different ways, depending upon the inclination of the road, okay, as well as the width of the overall road. Now, if you look at these pictures, you'll see that some of these retaining walls are actually holding up sections of the road. Other of these retaining walls are actually holding back earth from actually collapsing onto the road. So they're utilizing the techniques that they learned in the agricultural terraces to maintain these actual roads and keep them sound in their foundations. What we did find is that none of these particular structures have any mortar in them. So there are absolutely no mortar within these walls. They were all made from locally available field stones. Okay, so again, very sustainable. They use their local materials. And we got our ground penetrating radar out again to take a look at what was going on behind the walls. Because in the agricultural terraces, generally what you find is a drainage structure behind the walls, between the wall and the backfill. So we were hoping to find that with our ground penetrating radar system. Let's just say our ground penetrating radar system was a real disappointment because we never found what we were looking for with it, but it told us some interesting things. So what we found behind these walls, we didn't find any drainage structures. So what that led us to conclude is that the lack of mortar allowed for water to move through the wall, and allowing that hydrostatic pressure that would build up behind the wall when water would move behind it to dissipate through the walls. These are some of the pictures of these contention walls that we saw, just to give you an idea of the variation in terms of their thicknesses and how they actually were constructed. We didn't get to spend as much time as we would have liked looking at these walls, but one of the things that we did notice is the way that they were constructed, not only without having any mortar in them. In some walls, what we found was in the center, there was some earth, some compacted earth. And so we have a hypothesis that it may have been a mechanism to withstand the seismic forces, but we don't have any great conclusions about that quite yet. We're still continuing to look at that. Now, so they had walls, they dealt with water. Now, when they were moving through areas that were inundated with water, or potentially flooding in certain times of the year, they would build causeways to move through that wet, marshy area. Okay, and these causeways, they are just raised up a little bit off of the ground, and they will allow you to walk along when the area is covered with water. But the Inca understood the geotechnical properties of the soil, and they utilized clay to build this so that the water would not move underneath the road and would actually allow for the road to maintain its overall straightness. And we verified that. Here's Cliff digging in the area. We're looking at the actual materials that were used on the road. So we did do a little digging to actually make sure that there was actually clay that was being used for this. And so we verified that it was a clay material. So we saw the movement of water, we saw the support of the overall road, and we looked at the different materials that were used to build it. The other thing that we were absolutely amazed about was the way that the Inca constructed their road with respect to the alignment. We all know the shortest distance between 2 points is a straight line, and so did the Inca. They also understood the effect of adding distance would have on the traveler and the llama. And so that added energy that would take to actually move along the road, they were again very concerned about that energy. So not only the energy of water, but the energy of the traveler, which for those of you that have walked along the road at that elevation, you're really happy they're thinking about the energy you had to expend to move across the road. But when the Inca built, and what we were able to see, is that they employed the theory kind of directional straightness, and they connected their key connection points, say as mountain passes or river crossings, with as straight of a road as they possibly could. So when viewing the Inca Road from far away, so we shot this particular picture as we moved along the road. We looked back from where we had come, and you see that the road in profile is very straight with a very uniform type of grade. Now, how they actually were able to maintain and achieve that directional straightness in such a challenging environment is really, truly amazing, and it's a testament to their engineering skills. Now, in order to keep that directional straightness, Sometimes, if they absolutely had to, the Inca would excavate the rock, okay, to keep that directional straightness. And in doing that, again, it requires a lot of human energy to actually excavate that rock, so they would only do it when they absolutely had to. And they used the same techniques that the Romans did. Okay? They actually built a fire, heated up the rock, and then threw water on the rock and had it crack, and then they would begin to excavate through the rock sections. Okay? The grade of the Inca Road overall, if you look at the Andean environment, you've seen beautiful pictures today in the symposium from many of our colleagues. You notice that it's very vertical. Okay? It's a very vertical environment. And when possible, the Inca tried to follow the natural ground surface, but if they did have to construct stairs, okay, they would, out of rock, okay, that would help you move through very, very steep sections, again, trying to keep that directional straightness. And keep in mind, okay, when you look at the road in terms of the steps and moving, the llamas really don't seem to mind the steps. Okay, I think the humans minded the steps a little more than the llamas did. But so here's a traffic jam on the Inca Road, okay, with your llamas moving across the road. So when you think about the overall surface of the road and the location of the paving stones, it was really, just to protect the road from actual erosion from water, not from degradation by the actual travelers on the road. And again, the steps did not phase the llamas whatsoever. So before I finish and in closing, I really need to acknowledge several people. The National Science Foundation, the Museum of the American Indian. It has been a fantastic journey, and Cliff and I, we still pinch ourselves when we realize that we were actually able to be part of this. And there's many members of our team in the room, and we couldn't have done this without you all. So thank you very much. And we usually open up for questions, but I know we're not having any questions today. But one of the things that we got to experience while traveling on the road was we would stay in local villages every evening. And we had a lot of potato soup, but the potato soup was absolutely excellent. So this is a picture of us on one of our evenings, and we are at a pueblo at about 12,800 feet. It was very cold, and the way that we would determine how cold it was outside is we would look to see how much frost was on the llamas in the morning, and we knew how cold it was actually going to be. But this was a small pueblo just south of the Huacachura Pass, and we had an excellent experience, working with the local people during our expeditions. So thank you very much, and
Thank you, Cliff and Christine. We're actually making up a little time.